Looking at filtering from the impedance curve of a capacitor. Capacitors are often used for filtering in circuits, such as adding capacitors to the power pins of chips to filter out ripple and noise. The equivalent circuit of a capacitor under an AC signal is a series connection of a resistor, an inductor, and a capacitor. This resistor is called an equivalent series resistor and the inductor is called an equivalent series inductor. The impedance calculation formula for a capacitor is this one. This is the curve of the impedance of a capacitor changing with frequency, similar to a V-shape. The frequency corresponding to the lowest point of impedance is the resonance frequency of the capacitor. When the frequency is less than the resonance frequency, the capacitor exhibits capacitance. When the frequency is greater than the resonance frequency, the capacitor exhibits inductance. Filtering is to choose a capacitor with low impedance at the corresponding ripple noise frequency so that the voltage fluctuation on the capacitor is small and the filtering effect is good. This set of curves is Murata's 47UF to 1NF chip ceramic capacitor impedance curve. From this set of curves we can draw a conclusion that large capacity capacitors have low overall impedance, low resonance frequency, mainly filtering out relatively low frequency ripple and noise. Small capacity capacitors have high overall impedance, high resonance frequency, mainly filtering out relatively high frequency ripple and noise. As for aluminum electrolytic capacitors, their resonance frequencies are generally between 10 kHz and 100 kHz, mainly filtering out low frequency ripple and noise. Therefore, when filtering the power supply of chips, we need to choose the capacitance value of capacitors according to the actual frequency of ripple and noise, rather than unchangingly choosing a certain capacitance value. We often see multiple capacitors in parallel for filtering on chip power pins. For example, there are two capacitors with dashed impedance curves in parallel. Their resonance frequencies are F1 and F2 respectively. Then the equivalent impedance curve of these two capacitors in parallel is shown by solid lines with two relatively low impedance points. This can increase the frequency range of filtered ripple and noise. If multiple capacitors with the same capacitance value are connected in parallel, it will not change the resonance frequency of the parallel capacitors but will reduce the overall impedance of the capacitors. It is equivalent to multiple capacitors connected in parallel and reducing their equivalent resistance. It also has an effect on filtering out ripple and noise near that resonance frequency.